Hello, my dear students. Today we are going to study something about speed and velocity, and we'll also solve one question based on these two terms. So, let us start with speed. Speed is defined as distance covered per unit time, and from this definition, we can see that the formula for speed will be distance upon time, therefore, its SI unit will become meter per second. And it is a scalar quantity. As distance is a scalar quantity, therefore speed is also a scalar quantity. That means it has no specified direction. Second term is velocity, which is defined as displacement per unit time. Its SI unit is the same as that of speed, and it is a vector quantity, as displacement is also a vector quantity. Okay, these are very simple two terms, speed and velocity. Now let us try one question based on these two terms. In the diagram here you can see that a particle is moving along a circular path. Suppose it is moving with a constant speed. Let us say it's given a constant speed along the circle, and its initial position is also given at t is equal to 0. You can see in the diagram its position is marked. Now it is also given that after 2 seconds it is at the top. After covering an angle of 90 degrees, 1/4 of a circle, the particle reaches the top in 2 seconds. Okay. Now the radius of the circle is also given. Now let us try to find out some things in this situation. Suppose the first thing that we want to find out is distance covered in 2 seconds. Now in earlier video we have studied that distance is the length of the path. So length of the path is equal to the arc length of this quarter circle. So suppose we denote it as S. So we know that total circumference is 2 pi r. So we can see that it is 1/4 of the circumference. The length of the path covered between 0 and 2 seconds is basically 1/4 of the total circle. So it is going to be pi r by 2. Now r is given. So let us put the value of r. It is how much? 10 upon pi. So pi will get cancelled out and we get 5 meters. So the distance covered by the particle is 5 meters. Now let us come to another question. Let us try to find out displacement in 2 seconds. Okay, now we know that displacement is the shortest possible path from initial to final position. So initial position is at t is equal to 0, final is at t is equal to 2 seconds. So displacement is the shortest possible path like this. This is the displacement. So we can see that this displacement can be found easily by using Pythagoras theorem. So suppose we denote displacement by x. So we can see that x is equal to under root of r square plus r square. So it becomes 2r square. That makes it r root 2. And let us put the value of r here. 10 upon pi root 2 meters. Now this is the magnitude of displacement, and we know that displacement is a vector quantity, therefore it must have a direction also. Now you can see that north, south, east, west plane is given in the question, so we can clearly see that displacement vector points northwest. So we can write this is the magnitude of displacement in the northwest direction. Simple. Now let us come to C part. Suppose we are asked to find out the speed of the particle. Now we know that speed is equal to distance covered upon time taken. So what is the distance covered? In A part we have found it is 5 meters. Now in how much time is this distance covered? 2 seconds. So that makes it 2.5 meters per second. Simple. Now suppose we are asked that what is the average velocity in these 2 seconds. So we know that it is displacement per unit time from the definition given above. Displacement per unit time. Now what is the displacement? Again we have found that in B part 10 root 2 upon pi, and time taken is 2 seconds. So that makes it 5 root 2 upon pi meter per second in northwest direction. Velocity is a vector quantity, so we have to give the direction also in that. So I hope you enjoyed the video. Bye all of you.